Welcome to Adding Rational Expressions with Common Denominators and Binomial Numerators. This is a topic from Quiz 1 of Math 97. Let's look at our first example. We have a negative sign in front of a fraction plus another fraction. When we add fractions, we want to first check that they have a common denominator, and in this case they do. The common denominator would be 7a. So we can combine them into one. The second thing we notice is that this negative is out in front of the entire fraction, meaning that we could rewrite this as a negative 1 on the top times the quantity a minus 11x. So really we need to distribute that negative 1 on the top to change each of those terms. So this would be negative a plus 11x. Over 7a is the first fraction. And then the second fraction has a plus in the front, so its terms remain the same. 8a minus 3x over 7a. All right, now we can combine those two numerators into a single numerator over our common denominator 7a. So we have negative a plus 11x plus 8a minus 3x all over 7a. What we'd like to be able to do is combine like terms, and so think about the commutative property of addition. That allows us to change the order in which we add, and so if we would switch these two middle terms, we see that we'd have negative a plus 8a plus 11x minus 3x all over 7a. And now it's just a bit simpler to see that we have like terms. Negative a and positive 8a would combine and make positive 7a. 11x and negative 3x would combine and make positive 8x. We still have our common denominator of 7a. Okay, the next thing we want to do is ask, can this be simplified? In our case, because there is addition in the numerator, in order to simplify it, we would have to have some common factor between the 7a and the 8x. But unfortunately, 7 and 8 don't have any common factors, nor do a and x. And so we can't factor anything out that would cancel with anything in the denominator. And so this is our final answer. Okay. So let's take a look at a second example. For number 2, we have, again, two fractions, and we notice that they already have a common denominator. And so we can combine them. I notice that in this one, there is a minus sign in front of the second fraction. And so before I go further, I want to rewrite that as really a negative 1 being distributed over both of the terms in the numerator. So let's rewrite that as negative 1 on the top times 7c minus 11y. So this negative is being applied to both of those terms. So negative 1 times 7c would be negative 7c, and the negative 1 times negative 11y is positive 11y. Okay, so that's over 4c. Our first fraction, here it does have a negative, but you notice that this negative is only in front of the 6y. It doesn't apply to the entire fraction, only to this term. And so we can just write negative 6y plus c over 4c. What should go in between these? Well, I've already used my subtraction and rewritten that as a negative 1 times each of these things, and so there should really be a plus sign here. So you can think of always subtraction as adding the opposite. So we took the opposite of each of those terms in the numerator. So now this is a plus. So combine both of these numerators together, negative 6y plus c plus negative 7c plus 11y, all over 4c. All right, I notice that my two c terms are in the middle and that my y terms are on the outside. And so using the commutative property of addition, I'm allowed to switch the order of this as long as the signs go with the terms. So let's move this negative 6y to be next to the 11y. So I now will rewrite this as c plus negative 7c plus 11y, and then I'm bringing this negative 6y to the end. So I can either write it as minus 6y, or I could write it as a plus negative 6y. Those both mean the same thing. All over 4c. Combining our like terms, c and negative 7c makes negative 6c, and then 11y and negative 6y would give us positive 5y. All of that over 4c. Again, we ask, are there any common factors between the negative 6c and the 5y? And there are not, and so this is as simple as we can get, and this is our final answer.